Section 3.5. Limits at infinity. Let's take a look at the function f of x is, how about 3x squared over 2x squared plus 5. I want to know what's happening when x goes to infinity of this function. And I also want to know what's happening when x goes to negative infinity. What do you do? Any ideas? Take the derivative. That's almost always the right answer. It's not today. Good try, though. Good try. Right. We could do it the way we first looked at limits, is we built ourselves a table. So we could build ourselves a table, and we could plug in some big numbers. Or we could graph it and make our window really big and see what's happening. We'll do it both ways. James.
I was going to volunteer
A third way. Go ahead.
Well, I was going to say if you looked at it as the fact that the top has like x squared and the bottom has 2x squared, those are going to be equal as you approach infinity, so you can kind of ignore them and just use the values out front of the two highest powers.
So you're telling me the answer should be, and I agree with you completely, and you're doing it the algebraic way, which we will get to very soon. Very good. All right, well, let's do it with a table first. Let's plug in some big numbers. What are some big numbers? 10. 100. 1,000. 10,000. So we'll get to 10,000 eventually. All right, so I'm going to grab my calculator. Y equals, type in this function here. Oops. 3x squared divided by 2x squared plus 5. And then I want my table set up so that I'm on the ask mode. And that will allow me to just plug in any old numbers I want. So I go to my table. I plug in, I said 10, 100, 1,000, 10,000. And from plugging in those numbers, I'm pretty convinced when x starts to get to be a pretty big number, the y numbers are getting close to 1.5. So I'm pretty convinced that my limit as x goes to infinity is 1.5. And now how about as x goes to negative infinity? I would plug in negative 10, negative 100, negative 1,000, negative 10,000. And the y values did not change at all, which was very interesting. How come the y values did not change at all? Because of the square on top and the square on bottom, it reduced all the negative signs, didn't it? So I'm still pretty convinced my limit as x goes to negative infinity is 1.5. All right. Now let's take a look at the graph. That's an interesting little graph there. Do I have the standard viewing window? I don't think so. Zoom 6. All right, so what do we mean when we say x is going to infinity? What are we looking at? Yeah, what's happening when x comes over here and gets really, really, really big? And at this point, we're only going as high as 10, but already it looks like the graph is doing what? It looks like it's leveling off. Let's go bigger. Let's go, x goes from negative 50 to 50 maybe. And you can definitely see the graph is leveling out. In fact, the calculator draws it as a straight line there after a little while. So what's that called? That's called a horizontal asymptote. So when I'm asking you about these limits as x goes to infinity, what I'm really asking you to find are horizontal asymptotes. So, the limit as x goes to positive or negative infinity of f of x is the same as asking for the horizontal asymptotes. Now, my guess is somewhere in your life, in a pre-calculus type course, you've probably looked at horizontal asymptotes before. And you probably learned some pretty easy ways to compute the horizontal asymptotes. And this is what James was saying. If I'm looking at the limit as x goes to infinity of 3x squared over 2x squared plus 5, James looked at that and said, well, the power on top is an x squared, the power on bottom is an x squared. Those powers are the same. Since those powers are the same, I really just use the ratio of the leading coefficients. I think he said numbers out front. The fancy math words are leading coefficients. So James looked at that right away and said, the answer's got to be 3/2. And he's absolutely correct. So you don't have to show any work.
That is your work.
You can just write that. Okay? My question would be, why does that work? Yes?
I was going to say because both those numbers are increasing at the same rate, you have to consider that they have to be the highest too, because the ones below them aren't going to matter either. It's just going to be the two highest matching numbers.
Okay, so you're telling me that if I have limit as x goes to infinity of, say, 6x to the 5th plus 192x to the 4th divided by 4x to the 5th minus 3,256x cubed. You still believe it would be 6/4? Well, I believe that too, actually. I believe 6/4 is the right answer. But you're telling me that if I take a really big number like 1,000 and I plug it in 1,000 to the 4th times 192 doesn't matter?
Well, it's just not going to, insignificantly compared to the extra multiple of the number before it.
You're right. What really happens is if I take 1,000 to the 4th, even if I multiply it by 192, 1,000 to the 4th is quite small when you compare it to 1,000 to the 5th. So in reality, what happens is only the biggest powers matter. This cube, this 4th power here doesn't matter. This cube here doesn't matter. And what we'll do in just a minute is we'll actually prove that this does work by a technique. Correct. But that's the general idea. When you have these, it's really only the biggest powers that matter. And what it always kind of reminds me of a baseball player who's making $20 million a year. And he gets into a fight and the commissioner fines him $20,000. Does he care? No. If you're making $20 million a year, do you really care if you get a fine of $20,000? No, those fines levied on professional athletes are a joke. They should make them sit for 20 games or something, and then it would fix a lot of the problems. Anyway, I agree. The answer for this problem is 6/4. And here's why that works. We have a theorem. There's one theorem about these. And it says, if n is greater than 0, then the limit as x goes to, it doesn't matter if it's plus infinity or minus infinity, of a number, I'll call it c, divided by x to the n, is. So what happens if I take a constant c and I divide it by x to a power and the x value is getting really, really, really big? It's going to get close to 0, isn't it? If I take c and divide it by 100, that's going to be pretty small. If I take c and divide it by 10 million, that's going to be really, really small, close to 0. So this is 0. So that's our one theorem. All right, so here's how these work. I'll make up a new one. Limit as x goes to infinity of 4x cubed plus 6x squared minus 9 divided by 8x cubed plus 7. Based on what we said a few minutes ago, you should look at that and you should instantly know the correct answer is 1/2, because it's the power on top and the power on bottom are the same. The x squared, the 9, the 7 really don't matter. But here's what you do. If you really want to be pedantic and prove this. You take the biggest power on bottom. What's the biggest power on bottom? 3. So you're going to multiply top and bottom by 1 over x cubed. And you're going to distribute those through. So that would be the limit as x goes to infinity. What's 4x cubed times 1 over x cubed? 4. Plus, what's 6x squared times 1 over x cubed? 6 divided by x. Minus, what's 9 times 1 over x cubed? 9 over x cubed. Divided by, not very straight there. On bottom, we have 8 minus 7 over x cubed. So now, what happens when x goes to infinity? When x goes to infinity, what happens to 4? 4 is 4. When x goes to infinity, what happens to 6 over x? Getting very small, close to 0. That was our theorem. What happens to 9 over x cubed? Very, very close to 0. 8 is 8. Nothing's happening to that. What happens to 7 over x cubed? 0. So this is 4 plus 0 minus 0 over 8 minus 0. That's 1/2. When it comes time to take a quiz or take a test, do I need to see all that work? No, I do not. What I expect you to do is I expect you to write the answer is 1/2. Okay? Well, that works very, very well as long as the power on top and the power on bottom are the same. What if they're not? Yes, we do. Well, we don't just skip those problems. Limit as x goes to negative infinity of 21x to the 5th minus 18x cubed divided by 15x to the 8th plus 14x, I suppose. So notice this time the biggest power on top and the biggest power on bottom are not the same. What do you do? James?
Well, if you just said that anytime you divide by a number over a constant and the number on the bottom was basically bigger, wouldn't it go to 0?
Absolutely, this one's going to go to 0 because, again, you look at your biggest powers. Here you have an x to the 5th. There you have an x to the 8th. Again, when your number is getting big, when your number is like 10 million, how big is x to the 5th? Big. But how much is 10 million to the 8th?
Bigger.
By how much?
A lot.
10 million cubed, which is a lot. So when x is really big, this is going to be like having 1 over 10 million cubed. 1 over 10 million cubed is going to be very close to 0. But again, if you really want to get down and dirty and prove it, you do the same thing. You pick the biggest power on bottom. The biggest power on bottom is an 8. So you're going to multiply everything top and bottom by 1 over x to the 8th. And you're going to have the limit as x goes to minus infinity of 21 over x cubed minus 18 over x to the 5th divided by 15 plus 4 over x to the 7.
14.
Sure, 14. That's what I meant. Not what I said or what I wrote. Yes?
Now, if this were a true or false question on the test, if we start with the original problem and put and then we rerun and substitute x to 10 million, would that still count as an answer? Would that be proving it correct?
No, not really.
Proving that it's going to a certain time?
Yeah, I don't really want you plugging numbers in. You should just tell me the answer is 0. You really shouldn't show me any work at all.
Even on true or false?
Yeah. Or you simply say 0, power on bottom is bigger.
Okay, that works.
Something simple like that. All right, so what happens? 21 over x cubed, that one goes to 0. And this next one goes to 0. So that's 0 minus 0 over 15 plus 0. That's 0. All right, so those are pretty simple. If the power on bottom is bigger, what's going to happen?
Yeah.
You're always going to get 0 when x is going to infinity. If the power on bottom is bigger, you will always get 0. If the power on top and the power on bottom are the same, what's going to happen?
It's going to be whatever the
You look at the two leading coefficients. So what's the last possibility?
top is bigger.
The power on top is bigger. All right. So limit. X goes to infinity of negative 3x to the 4th plus 6x squared divided by 2x cubed plus 9x minus 8. The answer is?
So which infinity would win?
Which infinity wins? Well, it's not undefined. Well, it's not undefined. We wouldn't say undefined. Which infinity wins? The bigger one. Bigger infinity always beats little infinity.
But, because if you use the theorem you just said, you would end up getting multiple infinities the higher up you go with longer chains.
Okay?
You understand what I'm
I do.
Then how would you be able to tell if you ended up getting this number was approach infinity and then this number was approach infinity and you're multiplying them through and like one's positive, one's negative?
All right.
Negative infinity.
Does it go to negative infinity? I believe negative infinity is the correct answer.
Because the negative is out from the 3, which is the biggest power.
All right. So again, what we would do if we really wanted to prove this, we would, again, pick the biggest power on bottom. The biggest power is 1 over x cubed. We're going to distribute it through. So that becomes the limit as x goes to infinity of negative 3x plus 6 over x over 2 plus 9 over x minus 9 over x squared there, 8 over x cubed. So now what's happening when x goes to negative infinity? Well, down on bottom, what do I have? 2 plus 0 plus 0. Down on bottom, I have 2. 6 over x, that one's going to 0. When x goes to infinity, what's happened to negative 3x? It's going to negative infinity. So negative infinity divided by 2 is? Negative infinity. Our answer would be negative infinity. Questions on that? James?
So what would happen if, like, say you kept the bottom of that one similar, but you added in front of the negative 3x to the 4th, you added in like a 5, like a negative 3x to the 5th? Because in that, well, actually, you'd need a positive 3x to the 5th. Because in that case, you get infinity times negative minus, like, negative infinity.
Okay.
How do you take infinity and subtract infinity from it?
You don't. Limit as x goes to infinity of, you said you wanted me to throw in a what?
Just something that would end up making
A 3x to the 5th?
positive infinity. Yeah.
Minus 3x to the 4th plus 6x squared divided by 2x cubed plus 9x minus 8. So more or less the same problem. I just threw a 3x to the 5th in front there, right?
Yeah.
Same trick. I multiply by 1 over x cubed. Nope. Always use the biggest power on bottom. Always the biggest power on bottom. Because what you don't want to do if you were to divide everything by x to the 5th, then what would you get on bottom when you're looking at your limit? No. You'd get...
Negative x minus.
So when x goes to infinity, you would have 0 down on bottom. Because if I used x to the 5th here, I would have 2 over x squared, 9 over x to the 4th, minus 8 over x to the 5th. I'd have 0 plus 0 plus 0. I'd have 0 on bottom. That's a bad thing, isn't it? Can't have 0 on bottom. All right, so we would have 3x squared minus 3x plus 6 over x divided by 2 plus 9 over x minus 8 over x squared. Now, oops, oh my goodness, I forgot to write my limit symbol. Teacher would take points off for doing that, wouldn't he? Yes, I would. So now your concern is you have infinity minus infinity.
Yeah.
What's infinity minus infinity? Sometimes it's 0. Sometimes it's infinity. Sometimes it's any number in between. So in this case, which one is it? We don't know. All right. But I'm going to rewrite this. This is the limit as x goes to infinity. I'm going to take a 3x and factor it out of the first two terms. And just write down the rest of the stuff. So now, as x goes to infinity, what does 3x do? It goes to infinity. What does x minus 1 do? What's infinity times infinity? Infinity. So it's kind of a look at the biggest powers sort of deal again. Which power is bigger, the x squared or the x? The x squared. So which one's going to take importance? The x squared. So infinity minus infinity is really only a problem when your powers match. In this case, this power is bigger. I don't think this sort of example will happen in this class. No, but your answer would be infinity.
Okay, so there's never so we can always say that the power on top is bigger. It's going to be some sort of infinity. The power on the bottom is bigger. It's always going to be 0, and if the two match, it's going to be some value in the middle.
That's exactly perfect. So you just said exactly the right thing. If you have the limit as x goes to infinity of f of x over g of x, g of x has bigger power. So if you have bigger power on bottom, what happens?
0.
Answer is 0. F of x and g of x have the same power. The answer is the ratio of the leading coefficients.
And by leading coefficients, you don't mean the two numbers out front. You mean the coefficients directly, and you mean like the coefficients of the powers, right?
Correct. So if I had something like limit as x goes to infinity of 4x plus 8x squared divided by 9x squared plus 7, what are the leading coefficients?
8, 9.
8 and 9. 4 is not the leading coefficient, even though it came first. How come 4 is not the leading coefficient? Because it doesn't share the biggest power. This polynomial on top is not written in the right order, is it? Polynomials are supposed to be written so the biggest power comes first, and then the powers get smaller. So you're absolutely right. When I say leading coefficient, I mean the one with the biggest power. That one would just be 8 ninths. And all right, so back up here. If G has a bigger power, answer is always 0. F and G have the same power. Answer is ratio of leading coefficient. F of x has bigger power. Answer is going to be plus or minus infinity. You just have to figure out which one. No, not for this. It will always be 0, the ratio, or plus and minus infinity.
So why is it infinity when f of x is greater?
When f of x is greater, because you end up with this situation like we had back here, where when you reduce by the biggest power, there's still going to be an x left on top. But their number, you'll just have a number down on the bottom. So that's always going to happen. Anytime the power on top is bigger, you always divide by the biggest power of the bottom. Since you divide by the biggest power of the bottom, you're always going to have a power of x left on top. Okay?
So why does that mean that it's infinity?
Well, because your bottom's just going to be a number. And then what's happening as x goes to infinity? What's negative 3 times x when x gets really, really big? Negative 3 times x gets really, really negative, doesn't it? All right, what about this one? Limit as x goes to infinity of 2x plus 3 over the square root of x squared plus 5.
Like put the square root on the outside?
I could put the square root on the outside.
Isn't it still the same power?
If you can break it up with the rest.
I can't. I cannot write that as square root of x squared plus square root of 5. That doesn't work. Because it's an addition sign, square root of x squared plus 5 does not equal square root of x squared plus square root of 5. That doesn't work. Pick a number like 1 and convince yourself that that's not true.
Couldn't you square both though?
I could.
Top and the bottom?
I could, but if I square the top and the bottom of a fraction, does the fraction have the same value? If I were to take 3/5 and square the top and square the bottom, is it still 3/5?
No, I meant the whole thing.
So if I take 3/5 and square the whole thing, do I still have 3/5?
Never mind.
No, I still have 9/25, don't I? No, you can't just square the top and square the bottom. Unfortunately. Grace had the right idea. They really still have the same power, don't they? What's the power on top? 1. Just x to the 1. What's the power on bottom? It's really a 1, because what happens with a square root and a square?
That's what I was trying to say.
Yeah, you were right.
It's not that, because we're just looking at the leading coefficients, right? So it doesn't matter that you can't do that to the entire thing. We're just looking at what is the largest coefficient in there.
Yeah, you're exactly right. The one you only need to really worry about is the biggest power. The biggest power is x squared, but then I do a square root. What's going to happen with the square root and the square? They're going to reduce each other, so this is really just an x.
X and something else.
An x in other stuff, but the biggest power is still the x. So what's this limit? 2. Don't let those square roots throw you off. Still just look at your biggest powers.
That's with the biggest powers.
It does it in that case. All right, again, if you really want to get down to the nitty-gritty and prove this, here's what you would do. I'll write that same problem down again. Limit as x goes to infinity. What did I have on top? 2x plus 3 over square root of x squared plus 5. What you're going to do is you're going to multiply the top by 1 over x, and you're going to multiply the bottom by 1 over x. But you're going to write on bottom, you're going to write 1 over x in a fancy way. 1 over x is the same as 1 over the square root of x squared. Why do I think of 1 over x as 1 over the square root of x squared? Correct. First off, they are the same thing, but more importantly, now when I go to multiply, I have a square root here and I have a square root there. I can then multiply them together. So this becomes limit as x goes to infinity of 2 plus 3 over x divided by square root of, what happens when I take 1 over square root of x squared and multiply it by square root of x squared? I'm going to have x squared on top and I'm going to have this x squared on bottom. So that's going to be 1 plus 5 over x squared. And so again, what happens? This is 2, this one goes to 0, this one's 1, and that one goes to 0. So my answer is 2 over 1, which is 2. So the fact that I snuck a square root in there really isn't a big deal. Again, you simply look at your biggest powers and you realize the power on top is 1, the power on bottom is really 1. It's just written in a strange way. Questions on that?